Okay, so again, take the inside function to let u. So here we have u equal 1 plus x to the 4th. Taking the derivative, I see I've got 4x cubed dx. So rewriting this, I can see I've got x cubed dx. So I just need to divide both sides by 4. Okay, so this gets replaced with 1/4 du, and then I have cosecant squared of u. And again, I'm going to recommend you take the time to pull the numbers on the outside. And I can see that this is going to be negative cotangent. And then I put the u back in. Okay. Again, I want to let u equal the inside function. So du is 3/2 x to the 1/2. So if I rewrite this, with the root x beside the dx, I can see that I've got it right here. So if I multiply by 2/3, I get root x dx. All right, so this gives me sine, let me try that again. Sine of u, and then times 2/3 du. So 2/3 sine of u. So that gives me a negative 2/3 cosine of u, and I put the u back in. Plus c. Okay, so sometimes the denominator is a good choice, but can you see if I let u equal cosine? That's not going to be helpful. I'll get negative sine. That's not going to help. But we go inside the exponent of the exponential. So if I let u equal tangent, you see that du is secant squared. Do I have a secant squared? Let's just look at this, and I will separate it. Hey, you know what that is. That gives me secant squared, isn't it? Look at that. Okay, so this whole thing turns into e to the u du. And the integral of e to the u is e to the u. And then I put the x's back in. Okay, so this, you know, is the same thing as saying all of sine of theta cubed. And then there's a cosine theta. So I see letting u equal sine of theta is a good choice because I see that the cosine is right there. So this is du, so I get u cubed du. So u to the 4th over 4, and then put the u back in. And don't forget the plus c. All right, so sometimes letting u equal the denominator is a good choice. So if I let u equal cosine, du will give me negative sine. And if I was to rewrite this, I could write this as sine of x times 1 over cosine of x, right? So I see I do have a sine, I just don't have the negative. So negative du is sine of x dx. So I can replace sine of x dx with a negative du. And then I have 1 over cosine of x, or 1 over u. So this gives me negative 1 over u du, which is negative ln of u, plus c. And so I get negative ln of cosine of x plus c. So I'm going to continue these last few on the next video.